It says a manufacturer considers his production process to be out of control when defects exceed 3%. In a random sample of 85 items, the defect rate is 5.9%, but the manager claims that this is only a sample fluctuation and production is not really out of control. At the 0.01 level of significance test, the manager claim. What are we looking for over here? Proportion of mean or standard deviation? Yes, proportion. So whenever you have a percentage, it's going to be looking at a proportion. So our parameter is p. What is our p hat, our sample proportion?
0.059.
Yeah, so the 5.9% change to a decimal number, that is our p hat. What is our sample size? Okay, so this is the same type of problem we had before. We're looking for the proportion. What is our calculator command we're going to use here? Looking for a proportion. This is the very bottom over here. What's the shortcut on the calculator? 1 prop z-test. So we are going to use the 1 prop z-test. And how do we get to 1 prop z-test? Stat and then test. So 1 prop z-test is under letter A. So you have to arrow down. Now it says what is x, what is n, and what's our confidence level. So we don't have an x on our paper, so how do we find x? We're going to multiply. So x is just refers to the number of people or the number of items. So 5.9% or 0.059 times our sample size. This is going to give us a number over here. So 0.059 times 85. It says that's 5.015. What do we have to do over here? We're going to have to round it. Round up, round up. We should round it to 6? No, we're going to round it down. So we're going to round it to the closest. So it has to be a whole number, round to the closest. N is 85. Confidence level was oh, I'm looking at a z interval. We're in a z test. Hold on. Sorry about that. We were just looking up in the office hour at chapter 7. All right, 1 proportion z-test. Sorry. Okay, our P0. Let's set it up. So the claim is, well, let's figure out the claim. But the manager claims that this is only a sample fluctuation and production is not really out of control. So his claim is that P is what? Less than 3%. That's his claim. It's not out of control, so it's not greater than. Actually, it's even. If it doesn't exceed, then it's less or equal to 0.03. So here's our claim. Does this claim include equality? Yes. So therefore, it's going to go into the null. But in the null, we only write an equal sign. What is the symbol of the alternate? Greater than, right? The opposite over here. Same parameters, same number, but a different symbol. Very important, you guys. I don't want to just see you guys write like H0 is equal to 0.03. You have to put the letter, whether it's a P or a mu or a sigma. You have to write that down. Okay, so now we can go and calculate. What's P0? What is our claim? 0.03. X we already said was 5. N is 85. Our symbol in the alternate is greater than, so that's already highlighted over here. And so we're going to go calculate. Okay, the first line just tells us the alternate hypothesis. The second line tells us, first of all, what kind of test statistic it is. So it's a z. And then the number. Now, since it's a z, we're going to round it to how many decimals? 2. So that's 1.56. Okay, 1.56, that's pretty close to 2. Yes?
So you said x was 5. When I calculated 0.059 times 85, I got 5.015. Does that mean we don't automatically round up?
No. The only one where we always round up is when we're calculating the minimum sample size.
Okay.
Every other rounding rule is always going to be rounded to the closest one. Because we want to know how many of them were defective, right? So it wasn't like 6, it was 5. 5.0125, that gets rounded to 5.
Okay.
So yes, don't confuse those two. So it doesn't mean that sample size always gets rounded up. It just means when we're looking for the minimum sample size, we round up because we want to make sure that we have like the confidence level. We want to make sure we have the margin of error, and to make sure that is the case, we have to round it up. But for x, we're going to round it to the closest, so that's approximately 5. Okay, our p-value is 0.0596. So having a test statistic of something close to 2, our decision can be either way. It depends on our significance level. So our p, we're going to compare it to 0.01. P-value is greater than 0.01. So what was our conclusion? When the p is low, we reject the null, right? This p is not low, so therefore we're going to fail to reject. So fail to reject over here. So we can do our decision, based on the p-value. We're also going to calculate the critical value, which is going to give us that same decision. Okay, is this a right-tailed, left-tailed, two-tailed test? And how do you know what it is? What do you look at? Yes, Adam.
I look at your claim, so I'm guessing it's a right tail test?
Actually, you are looking at the alternate. So this is right-tailed. Okay, what's the area in the right tail? When we're determining our critical values? What's our alpha in our example?
0.97?
So alpha is actually our significance level. That's the area in the tails, which is 0.01. Okay, in a one-tail test, the entire alpha goes into that tail, so that's 0.01. So what's the area to the left? Because our inverse norm always gives us 0.99. We're now going to use inverse norm. Inverse norm gives us critical values for the z-scores, 0.99, 0, and 1. Okay, what's that score? What's that critical value? All right, let me check 0.99. 2.33. Rounded to, so the critical value is a z-score again, that's rounded to 2 decimals as well. Okay, if this is 2.33, we're going to look at where does our test statistic fall. And it falls right into that middle area, into the fail to reject zone. So we look at how unusual it is, and we're going to determine, well, it's not really that unusual. Because everything in the tail is unusual. That's our rejection area. When we reject the null, we're going to cross it out. And then we're going to look at the final wording. Did our original claim include equality? Yes, so we're on the top. Did we reject the null? No, right? We failed to reject it. So what is our wording? Right there. There's not sufficient evidence to warrant rejection of the claim. And what was his claim?
Production is not really that equal.
Mm-hmm.